A triode is a semiconductor device that controls current. It can amplify weak signals and also acts as a contactless switch. In new energy vehicles, it is often used in wheel speed sensor signals, in Cartier lights, and other components. The contactless switch function of the triode is often used. In this class, we will learn about the structure and characteristics of triode. According to the structure, triode can be divided into NP and NPN types. NPN triode are controlled by applying a high voltage to control the conduction of the triode C, while NP triode are controlled by low base voltage to control the conduction of the triode C. NPN and PNP triode are used in power amplification. Circuits are generally used together. As shown in the figure, there are two PN junctions inside the triode. One is called collector junction, and the other is called emitter junction. A triode has three: collector, emitter, and base. The characteristics of triode. The characteristics of triode mainly studies the base current of the triode. Collector current IC. The relationship between the collector and emitter voltages UCE. A triode is a device that controls current by current. It can also be said to be a current amplifier. As shown in the figure, this circuit diagram has two circuit loops. One is the control current loop, and the other is the controlled current loop. Circuit 1 in the figure is composed of power supply UB, B, resistor RB, triode base B, and emitter E. The current starts from the positive pole of UBB and enters the triode base through RB, and exits from the emitter E of the triode, and returns to the negative pole of UBB, forming a complete loop. This current is called IB. Circuit 2 is shown in the figure. It is composed of power supply UCC resistor, RC, and the collector C and emitter E of the triode. The current starts from UCC positive pole and enters the collector of the triode through RC. It comes out from the emitter E of the triode and returns to the negative pole of UCC to form a complete circuit. This current is called IC. Based on the states of IB and IC, we can judge that the triode is in the cutoff, amplification, or saturation states. When IB is 0, IC is almost 0. UCE is not 0. This state is called the cutoff state of the triode, also called the cutoff region. When use voltage is sufficient, IB increases from 0. IC also increases, and there is a relationship between IC and IB. IC equals beta times IB, where beta is the current amplification factor. In this state, IC is controlled by I. This state is called the amplification state, also called the amplification region. When a triode is used as an amplifier, the triode works in the amplification region. The linear region of the triode is also called the amplification region. When used as an electronic switch, the triode works in the cutoff and saturation regions. When the CE pole of the triode is not conducting, it is called the cutoff region. When the triode is fully conducting, it is saturation region. The characteristic curve of a triode. To better analyze the characteristics of triode, we express the relationship between IB, IC, and U's in the form of a curve. This coordinate curve is the characteristic curve of the triode. The vertical axis describes the size of IC current, and the horizontal axis represents UCE voltage. The middle curve represents the relationship between IC and UCE at different IB currents. Now let's look at the curve, with IB equal to O. When UCE increases from O, IC hardly changes, which is close to O. Through this curve we can analyze that. When IB is equal to 0, we can infer that IC is 0, which is the cutoff working area of the triode. Let's look at the curve with IB equal to 60 microamps. From the curve, we can see the relationship between IC and UCE. When UCE increases from 0 to about 3 volts, IC increases with UC. In this state, IC is controlled by UCE. The triode is in saturation region. When UCE is greater than 3 volts, IC hardly increases with UCE, but remains almost constant. At this time, the triode enters the amplification area, also called linear region. At this time, the IC current is mainly controlled by IB. Other curve laws are the same as this curve. This is the characteristic curve of the triode. The structure and characteristics of triode are abstract during the learning process. We need to pay attention to master the characteristics of the triode as a contactless switch, the characteristics of current, amplification of transistor, and apply what you have learned. Learn the knowledge of transistors well, laying a good foundation for learning the control circuit of new energy. A 9-story tower rises from the ground. Whether in future studies or life, I hope you can lay a solid foundation and move forward steadily.